Okay. So then we'll continue discussion on our methods of that that are there in list. So um, we have something called as sort and reverse. Okay. Um, okay. So for that, I have to create another list which has same data type. Okay, list or string. So I'm going to create a numeric value integers. Okay. So let's say you have 90, 20 dot 20, 50, 40, 30, 70. Let's say these are the values here. Okay. Now I say print list to, okay, dot reverse. Okay. Okay. So what do you get here? None. Output is none. Okay.
Okay.
So I'm going to talk about what it means. Now here, if I do list to dot sort, okay, get none. Here also you got none, right? Now, when you talk about methods or functions rather, right? It's basically it's function, right? So there are two types of function based on return values. Okay. One is, let's say you pass something to return function, okay, to the function, and function gives back something to you. Okay. Second option is where function doesn't return anything to you. It does its job and that's it. Okay. So when it does not return, that's when you get none. It does not return a new value, which means that, you know, it has already changed the value. Okay. So the list 2 has been changed. Okay. Obviously list 2 is here. Now if I print here list 2, okay, and if you print again list 2 here, okay, so you see list 2 has been reversed here, 70, 30, 40, 50, 20, 90, right? It was 90 to 70, it became 70 to 90, and here it has sorted the list in 20 to 90, correct? So it has sorted, it has changed the order or whatever, like depending upon the function that you're using, sort or reverse, it has done to the main list itself. Okay. So it's not returning the list to itself is sorted or reversed. Okay. So okay, so instead of doing print, you can directly say list to dot reverse, and then if you print list to, it is reversed. You can directly say list to dot sort, and you can print list to.
So just one question. So when we give that function in print, it should print the same list to, right, after getting reversed.
No. See, it is not list to. It is list to dot reverse we're trying to print. We're not trying to print list to, isn't it? We're trying to print list to dot reverse. List to dot reverse does not return anything. So it doesn't give you anything. So it's printing none. Okay, so it is different than printing list to versus printing list to dot reverse. We were printing list to dot reverse, not just list to. Correct or not?
So my question is, when we do list to dot reverse, if we put that entire thing in print function, it
That's what
should
I'm
print
saying.
that reversed
When you're
list, right?
when you're putting entire thing in the print, that means what? You're trying to print the entire thing. Yes or no? When you put entire thing into the refrigerator, it means you're putting entire thing in the refrigerator. Correct or not? You cannot say that no, the only bottom should get chilled, top one should not get chilled. Is it possible?
So my question is, we actually reversed that list two, and then we are printing that list two, right?
No, no, no. That's what I'm saying. We are not printing list two. This is where I'm printing list two. See, wait. I'm not printing list two here, right? It is list two dot reverse. You understand this? This is different. Then what's the difference between this and this and this? What is the difference between
Yeah,
line number 4 and 5?
yeah, that's what
There
I'm
has to no, there has
asking.
to be some difference, correct?
So when we print list two, it should print 90,
List
20,
2. It will
40,
print the
40,
value of
30.
list 2, whatever it is.
Yeah.
Okay.
So
Depending
when,
upon where you are printing, it will print whatever the list 2 has at that moment.
yeah.
Correct? And now when you are seeing list 2 dot reverse, you are printing list 2 dot reverse. List 2
Mm,
dot reverse doesn't give anything, does not have anything. List 2 dot reverse is a function. List 2 is a variable. List 2 dot reverse is a function. Okay. So if you have two part to a cake, right? This is like passing the just the base thing. This is like passing the complete cake, right? Both top and bottom part, right? You cannot say that it should give me should only chill this one, but it should ignore this. You know, it cannot ignore, right? There has to be some difference between line number 4 and 5. What you are saying is 4 and 5 should give same answer. How can it give same if they are not same? There has to be some difference, correct? Difference is this is a function and this is just a variable. Okay, list2 is a variable which is of type list. List2 dot reverse is a function. Some function returns value, so it will print the returned value, not the list2. So this is a function here, right? We are ending with bracket. Ending with bracket means it's a function. Right? Now, see, when you say a equal to 5, and now I'm saying print int of a, okay? So int of a, int is a function which will
mm,
convert 5 into string 5 into integer 5, right?
mm,
It will convert
mm,
integer 5. So output of this function is 5. This is
mm,
also a function, but this function is returning a value 5. So that's why you get 5. Not because it is printing a. We are printing int of a, not a. Okay, we are not
okay.
printing. It's not, the output is 5, not because we are saying print a. Output is 5 because int a returns 5. Here, the dot reverse doesn't return. That's why you're
Yeah.
not getting.
Yeah, yeah, I understood. If we give something within that bracket, then it should return value. But we
No,
are
no, no,
not
it's not,
giving
no, 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 no,
anything
no,
when
no,
it's
no,
to the
no, no,
reverse
no,
process.
nothing like that. It depends upon how you design the function. And when we get into function, we will see that. It depends upon function definition. Okay, so I give this example. When you go to a Xerox shop, right? You give your original document and you get a document back, right?
Mm,
But when you go to bank to deposit money, you give money, you don't get back money, isn't it? It gets deposited into your account, something like that.
mm,
It depends upon the process, depends upon what you're trying to do, how you have designed the function, how you have written the function. So in the function, if you have not done the return part, okay, then this is like this. This reverse does not have return type. This function has return type. What you give in the bracket is the input value, not the output thing. Okay. Output, what should be output is designed or defined in the function. Okay. The person who has defined the function has control. You don't have any control.
mm,
Okay. If you don't like it, you write your own function. I don't like this reverse. I want reverse to return. Then you write
mm,
your own function.
okay.
Right?
Mm,
So, since we have not done function, so maybe may not be the right thing, but let's do a function here, sample function. So this is how you define a function: def my reverse. I don't like this reverse. Okay. So I'm going to say my reverse. So my reverse, the function which I'm writing. Here I'm going to take A. Okay. And you have to give colon here. And then I'm going to say B equal to A dot reverse. Okay. Now I'm saying return B. Okay. Now I'm giving return B. Now my reverse will behave different than this. So if I say here, okay, print uh, put some comment here, my reverse. My reverse, my reverse, and I'll say list 2. Okay. Now in this case, my reverse list 2 will give me, oops. This also says none. No, it should not be none. So my reverse bracket list 2 is here. Let's print here first. Print B. Okay, the value is not going into it. Okay, that's the problem. So see here also it's none.
We did not give any value for A. Is that why it's not returning anything?
No, but I'm giving here, right? A. So A will get list 2. A equal to A. No, it's not. A equal to is also not getting printed. Wait, let me comment all the print. Okay, so maybe it's confusing. So let's. Now the suggestions becomes big problem. I have increased the font size so that it looks better on screen, and it's creating problem with the real state, and that's why all these options are getting on it. Let's run it. So A equal to, A equal to, so A is getting printed here. And now, so it's a list. So now B, okay. Now I'm going to say, or directly instead of B, right? Because it does not return, I'll say return A here. Okay. Now you'll see, you'll get the value because function doesn't return. So B will not have. Okay. Now, okay, it's print A. Now I can do return A. Okay. Now you can do return A. So when you say return A, so see the value is printed here. So two things you have to keep in mind. One, okay, it depends upon what you are returning here. I'm returning A here, right? I can simply say A dot reverse and return A. So now when you say return A, that's when this print will print some value, whatever you're returning. If I return A of 0, let's say, okay, then output will be only your first value, which is 90, right? Whatever you're returning, that will only be printed in print. Okay, first thing to remember. Second thing is the whatever you give here, okay, this is the input value, nothing to do with the output. So this goes here for A, okay, and why don't we pass anything here in list dot sort or list dot reverse? Why don't we pass anything here? We don't pass anything here because this is a function within the class list. So when we define this list 2, okay, so when you define into list 2, there are two ways. Okay, one is the class level variable and object level variable. In this case, it takes object level variable. So reverse will have access to all the members of the list. Okay. So that's why, when we say list 2, it reverse knows that, okay, I have to work with list 2 values. That's what list function knows. Or list or reverse or append or insert, whatever. Where to insert? Append, you are giving some input value. Remember, insert and append, we gave some input values because it needs a new value to get added. But reverse and sort doesn't need new value. Whatever value is in the list 2, you operate on that same value. That's why we don't pass anything here. Okay. But if it has return type, if you print will give you value, otherwise you won't get the value. Okay. And of course, same thing with sort. Sort will also do same thing. Then there's something called as extend. Okay. Extend is same as list 1 plus list 2, but there's a difference here. When you add two lists, you can save in a third list. You can say list 3 equal to list 1 plus list 2. So yesterday we saw that, right? List 3 equal to list 1 plus list 2. It will add these two values together. So you get a one single list with these values. Second option is you say here list 1 dot extend. And then you say here list 2. So it is like saying list 1 equal to list 1 plus list 2. List 1 equal to list 1 plus list 2. So your list 1 will have the new set of values. Okay. New set. Got combined here. Right? Got combined. Make sense?
Yeah, yeah.
Okay.
Hello?
Yes, yes. There's one last thing that we'll discuss. It's it's a very interesting thing. Let me take list 2 here. Okay. I will take list 2. Okay. So I'm going to say print learning copy. Okay. So I have list 2 here. Now I'm going to say list 3 equal to list 2. Okay, list 3 equal to list 2 and list 4. Okay. Equal to list 2 dot copy. Okay. So I'm saying list 2 equal to some value. Okay. And list 3 equal to list 2 directly, and list 4 equal to list 2 dot copy. Okay. Now, obviously, when you print some list 2, if you print list 2, okay, you will get list 3, list 2, right? So obviously, all three should have same values, right? Because we are doing copy here and you're going to equal to here. What is the difference between these two? What between copying, creating a new list using equal to, or creating a new list using copy equal to? Okay. So I take list 2, okay, and I append a new value to it. So 10 is not there. So let me add 10. Okay. Now what happens? Do you notice anything different here? Uh-oh, this is all list 2, my mistake. This is list 3, this is list 4, list 2, list 3, list 4. Okay, what do you notice here?
But appended value is not getting copied, right?
Correct,
List.
correct. So when you do copy, it's like doing photocopy. Okay, when you do photocopy, what happens? A new set of files are created, isn't it? Okay, so new copy is created. So the moment you create, when you do copy, at that point it copies the same element and they are different. So list 2 and list 4 are different. Okay, but when you do equal to, it is like giving a different name to the same list. So list 2 and list 3 in this case will always have same value. There's only one copy, okay, but you're giving two name. Okay, so you're giving, when you say equal to, you're giving it a different name, that's all. So list 2 and list 3 will have same set of values. It's like, all of your family member have same address. So if something is sent to you, you will get it. If something is sent on your son's name also, you'll get it. Okay, so list 2, list 3 are like family members. Okay, but list 4 is different. It creates a different, it copies the element at that moment and creates a different set that separate from list 2. So whatever you do with list 4, only list 4 will reflect it. But whatever you do with list 2 or list 3, both list 2 and list 3 will reflect it. Okay, so we call this as deep copy. Which one? This one. Deep copy. It's actually copies and goes away, right? Separate way. Here's called shallow copy. It copies, but really not copy, right? It's pointing to the same memory location. So again, depends upon your business case logic. You need to decide which one to use. Make sense? Any questions you have for me? Right? So these are different ways of doing stuff in list. Okay. Now let's do an example. Okay. Where I'm thinking we'll have an empty list. Okay. And then based on your preference, we'll keep playing with it. Okay. So for example, I'm going to create a list master something equal to blank. Okay. And now I'm going to say while true infinite loop. Okay. I'm giving you options. Okay. So print add. Okay. So see, list is called data structure variable, the way you implement it. Okay. And there's some theoretical concepts around data structure. Okay. So one of the theoretical concept in data structure is called stack. Okay. Now stack stands for last in, first out. Okay, so stack will have only one way to remove the element. Okay, so it's like this. When you say that stacking of things, right? If you're stacking up plates, what does it mean? You put your first plate, on top of that, you're putting second plate, isn't it? Stacking plate, right? Then third will be on top of that. Fourth will be on top of that. The last, let's say 10 plates you have. So 10th one will be on topmost layer, right? Now, if you have to start taking out, which one will you take? You will not lift 9 plates and take the bottom one, right? You take the first plate, then the second plate, then the, sorry, 10th one, then the 9th one, right? So this is called stack concept, okay, stacking. Okay, here the last element that you have put in will be the first one to be taken out, right? Last element that you put in has to be the first element that you take out. That's why you call LIFO, last in, first out. Then second concept is called queue. Okay, when you stand in queue for something, in queue, first person to get in is the first person to get out, isn't it? If you're first in the queue for movie ticket, you'll be the first one to get the movie ticket and you come out, right? Last one will be the last one to get the ticket, right? So that is called queue concept. And there you have FIFO, first in, first out. Correct? Now, using list, I want you to implement stack and queue. So maybe I'll do stack, okay? And you do queue similarly way. So what are the things that you can do? Okay, so I'm going to say, okay, I'm going to print it before we go. We say print stack implementation, right? Now I'm going to say option 1, add to the stack. Okay, print remove from the stack. And last one I'll say clear the stack. Okay, and option 4 is quit. Okay, now I'm going to say enter your option. Enter your choice or option. Okay, now enter your option should be your input, isn't it? So I'm going to say OP option equal to int of input, right? Done, right? So now I have to implement for each of these 4 options, correct? So I'm going to say here, if OP equal to 1, then do something, correct? Elif OP equal to 2, then do something. First, I'm going to create this structure and then I'll go and add one by one the logic to it. Elif OP equal to 3, again, then do something. Elif OP equal to 4, do something. And you have only 4 options, right? So if you get anything other than this, what is the print? Invalid option, try again, right? Now let's run this loop, right? So you got this, right? Okay. Add to the stack, remove from the stack, clear the stack, quit. Okay, so I give 5. Okay, invalid option, try again, right? 5. Invalid option, try again. So I'm going to stop this program. Okay. Um, okay. Okay. So should be practice. There should be a round option to stop. I'm just looking for it. This is practice 2 only, right? Practice 2. Okay. So invalid later. Take. So now when you go to quit, option 4 is quit. Correct? So I'll say print. Thank you for using the program. Okay. And now I'm going to say exit. Exit is a command which will it'll stop your program, right? So option 4, thank you for, it'll display the message and your program will end. Okay. Now clearing the option, stack 3, right? So we have master list master dot clear. Done. This is clear. Now you see, add and remove. Now, add means what? It has to be added at the end, right? So if you uh, in both the case, okay, in stack and queue, you're adding at the end. So append will do the job, correct? Append will tell you which is the first element, which is the last element, correct? So simply I'll say val equal to int of, assuming that it's only integer values, enter the element to add, okay, and then I'm going to say list master dot append val, correct? So value will be added at the end. Now remove. So remove, now you see, remove is typical. The last element has to be added, okay? So we have two options, remove and pop. Which one will you use?
Should use pop only, right?
Yes. Okay, in both stack and queue, you have to use pop because both stack and queue is based on the position, correct? So position, okay, is we use pop, right? Remove is where we take the value to remove. Both in stack and queue, implementation, you will use pop only. But pop what?
The
List
size.
master dot pop. Pop what? So here pop last element. What is the last element? Last element is nothing but your -1, isn't it?
Okay.
Index starts from 0 to n-1 and forward this thing. Backward, it gets from -1 to -n, right?
Yeah.
Is it correct? And
Yeah.
you can have, you can display the value after doing every operation. So after adding list, comma, master list, so that or you can add fifth option called print here itself. Up to you the way you want to implement it. But I want to see after every operation what's the output, right? And clear also. Now when I run it, okay, so when you say, see, the logically your program is correct, probably we'll see that. But now see, okay, initially my list is empty, isn't it? Master list is empty. Now I'm trying to remove the value from this 2. What happens? You get index error because list is empty. There's nothing called -1 here. Right? So before you do that, okay, you have to check the condition, right? This is called error handling. Okay. Okay. If len of list master, okay, is greater than 0. Okay, if it's 1, it's fine, but it has to be greater than 0. Then you do list master pop and print. Else, okay, print list is empty. Okay. So now when you run it now, so remove from the stack, I give option 2. Oops. List and int. Something went wrong. Oh, this is len of, sorry, this should be outside the bracket, right? Len of this should be greater than 0, isn't it?
Yeah.
So option 2. See, list is empty. Option 1. Element to add 34. Okay, list is 34. Again, I say element to add. Okay, 54. Get 54. Keep on adding, correct? I say 4 will come out, right? And you can start building it, right? You can say, do you want to reverse the list? Do you want to sort the list? I mean, reverse, not much you use, right? Sort, you want to sort the list, right? So these are things you can add, and you can develop your queue implementations on similar line. Yes. Okay. Okay. So this is what these are the things that we discuss in list. We are done with the list. Okay. So complete your assignment on the list. Okay. The next topic that we're going to talk about is called tuple. Okay. Now, tuple and list are very similar. Both are, we call them as linear data structure, linear collection of data structure, linear collection, because it's in one line, right? In linear fashion. The difference is your tuple is immutable version of list. String is immutable, list is mutable, tuple is again immutable. Okay, it means that it will not get edited. What will not get edited? Values won't be get edited. Now, so when values doesn't get edited, we did so many functions, right? Methods in the list, correct? How many of these methods you see is about editing the values? Append, is it about editing the values?
Yes.
Yes. Insert, is it about appending the values?
Yeah.
Yes. Um, Extend, is it about editing the values?
We didn't discuss
Extend.
right?
No, I mean, we did discuss extend, right? List to dot extend is like,
Oh, okay.
right? So we said that it is like adding list one equal to list one plus list two.
Yeah. So that is not it.
This is also mutability. Yeah, we are appending, right? We are changing the list one, right? So all these functions, okay, are not available in tuple. So it's like list without these functions, isn't it? So easy to remember. There's nothing here. So first thing I have to remember is how do you define a tuple, right? So tuple is defined. Okay, let's say I say T1 equal to lists are defined using square bracket, right? Tuples are defined using simple bracket. So here you can give 5, 4, 6, 8. So we have tuple here. Now print type of T1, okay, you get, I have to do the quit, okay. Okay, exit means will throw you out of the program itself, okay. So
okay, we have to give a break, right?
you have to give break here. Yeah, right. So for now, let's give break. It will throw you out of the loop. Break will throw you out of the loop. Yes, you're right. Okay. So 4, see, it gives you class tuple. Okay. It's tuple. Now, when I say T1 dot, you only have count and index. You do not have append, insert, pop, remove, extend, okay, even sort and reverse, because those also involve changing of values, right? Within list one, you are changing the values, right? Or reordering. So all those functions are not there. So then what's the use of tuple? Okay, tuple is like your one-way road, because you sure that you cannot edit, so the reading becomes much easier and faster. Okay, so when you are doing reading of the values, you say you declare as a tuple. Okay, tuple will make reading faster, so you say tuple as reader. Okay, so but when you want to write, of course, you can't edit tuple. So what we do, your tuple and list can be converted to each other format. So if you are using in for loop, we discussed using in for loop list, right? So in such case, you convert into tuple and use it in for loop, because for loop will be faster when you have a tuple. Okay. And if you want to add some value, I want to add value to tuple. So you say T1 equal to list of T1. Okay. Your T1 has become now a list. You see, all the options are available here.
Okay. So if we want to edit a tuple, we have to convert it to list and then only we can
Then
put
only can
comma.
happen. Yes. Okay. We did not discuss count, right? Count will count how many particular element is there. So if I, if 5, 4, 6, 8, and let me put another 4 here, let's say. So if I say count of 4, okay. Now in this case, okay, you can put a print because this is returning 2. This function returns 2. So in this case, you can say, so 4 is 2. Right? 2, 4. If I say 8, of course, you get only 1.
Okay.
Okay. So that's how these things work. So nothing much to discuss in tuple because there's no functions. But few things you have to remember is tuple is faster in accessing than list. So we prefer a tuple when you are doing reading operation. Second thing is, okay, in declaration itself, okay, when you have a no value, if you want to declare an empty tuple, okay, then also it's fine. Okay, you can declare like this. If you have 2 or more than 2, is fine. But when you have only one value to declare in tuple, right? So if I give like this, let's say you have only one value, 55 to add. Now, Python gets confused whether it is a value that you have given in a bracket, mathematical value. Bracket is also used for mathematics, remember? Simple bracket. So it gets confused whether it is a mathematical bracket or tuple bracket. So it will assume it to be like a mathematical bracket because mathematical bracket is very common, right? So it will assume it to like a mathematical bracket. So if you have only one value to add in a tuple, you just say comma here, 55 comma. Okay, you have to give extra comma only if you have only one value, because otherwise your Python tuple will assume that it is Python will assume that it's a mathematical bracket, not a tuple bracket. To make it a tuple bracket, you have to say comma. So if it is empty, see, you don't give empty bracket in mathematics. So it assumes that it is tuple. When you have more than 2, you don't say comma in mathematical operation, right? You have mathematical operators, not comma. So it assumes that it is tuple. But problem comes when you have only one value. So it takes the basic one, okay, which is mathematics. So if I say T1 equal to bracket 1, and if you do the type, it will give you integer type. Okay. So which is not correct. We want to declare the tuple. So you say comma. Okay. Only for one value. You have to remember this. Otherwise, everything else, it's normal. That's it. So we are done with tuple as well. So we'll stop here today.